Hi everyone, welcome to GPSTEC337. My name is Judah Bernstein, and here with me I have Ranjith Raman, and we are Senior Partner Solutions Architects with the AWS SaaS Factory team. Go ahead and pick up your headsets if you're not wearing them. This is going to be a silent session, so it'll be challenging for you to hear things. We're on a team called the AWS SaaS Factory, as I mentioned, and the SaaS Factory team is really focused on helping technology as a service vendors, ISVs, and technology companies with building and transforming their businesses by delivering SaaS or PaaS-like products. Today's session, we're going to dive deep with you technically to talk about how to build a platform as a service offering using Amazon's Elastic Kubernetes service. So, what important thing to be aware of is that today's session is not meant to be an introduction to Kubernetes. I have this slide only to set the context that you should already know Kubernetes and its primitives if you're here today. I'm not going to talk about what a pod is or what a service is. There's a large number of sessions for that. I'm going to talk about multi-tenant design considerations through building a PaaS layer with Kubernetes, the community, and its primitives. So let's get started. So what is platform as a service, right? So one of the things to think about is a PaaS solution allows customers, right, to not have to worry about the undifferentiated heavy lifting of managing infrastructure for powering these applications by having a provider operate them on their behalf. Many of you may be familiar, right, with vendors such as Salesforce Heroku, or maybe our offering within Fargate that is a PaaS-like solution. What we're going to do is we're going to talk about how you could build this platform as a service solution. And we're going to talk about it through a couple core requirements that we're going to set the scope of this session. So one is we're going to talk about how we're powering external customers' custom applications, scaling these applications for them, ensuring that these customers don't have to worry about deployment and that all they have to do is commit their code to some type of Git repository, that we want to provide multiple language support. Perhaps your customer is operating Node.js or Java with Spring Boot as an application, and you're powering this for them. They don't want to worry about what code they're committing. You need to power any type of application for any type of language that's common. And finally, you need to ensure that it's secure and that it's compliant. So, with that said, I want to start by walking you through some core pillars of multi-tenant design, and then we'll talk about the core sections we're going to cover in today's session. So one thing to remember is there's this concept of a silo. A silo is a single tenant infrastructure or application instance operating one customer and that customer's users. Typically, you'd find like a product deploy that's deployed in a managed services style would look like a silo configuration. A pool model is a little different. It's multi-tenant. It's where you have shared infrastructure or an application instance powering multiple customers and those customers' users. So the pool model is important to remember because today's session, we're going to focus on how you could use a pooled EKS cluster specifically. There's also a model that often we see in production, and we have to be realistic about what we see in production when we're working with ISVs. Some ISVs that are building SaaS or multi-tenant applications, they want to ensure that certain resources are dedicated per tenant in the silo configuration, while other resources might be comfortable and acceptable to share. The bridge model allows you and affords you that capability. One common use case that each of you are familiar with is where you might have like a shared application and web tier, but where that database cluster or database might be single tenant instead of having like a shared schema. So a couple core fundamental categories that we're going to dive into in relationship to Kubernetes today. We're going to talk about how you could achieve compute isolation. We're going to talk about how you could achieve network isolation. We're going to talk about how you could tier your products and your offerings for this PaaS layer. We're going to talk about how you achieve storage isolation. We're going to talk about usage metering. This is how do you know what your customer is consuming in your platform and how you could charge them for that usage. Especially in a platform as a service, this is crucial because you're going to be charging them based on what they're consuming in your resources. And finally, advanced architectures. We have a limited time, so there's a whole bunch of things that we could cover in this session. But we're gonna run through some of the top level things in much more detail And we're going to cover only a sliver of advanced architectures, but just enough to whet your appetite to talk to us after the session and tell us what you need. So with that said, let's talk about what a typical multi-tenant Kubernetes workload architecture looks like. It's a mouthful, I know. But what's important to remember is that you are looking to use an EKS cluster and the worker nodes that you have to power multiple tenants. So here you can see I have one tenant within a namespace. We'll talk about what a namespace is and how it is not completely secure and sufficient. And we have some type of approach to being able to isolate tenants from one another through maybe some type of network policy or approach that you would typically find. This is the end state of the architecture that we want to achieve at the end of the day. Imagine that your customer, customer A, is a typical customer that's uploading their application to your PaaS layer through some type of API that you provide. What you're going to do is you're going to power on their application within namespace 1, right? And you're going to isolate them there, and you can power other tenants or customers in the system through the same cluster in different namespaces. There's a lot more to it than that, but that's the most primitive approach that we can do to highlight what our end state looks like. So I have some bad news for you here. So today, Kubernetes does not support native tenant isolation. And we, Amazon EKS, which allows you not to have to worry about the undifferentiated heavy lifting of managing the master nodes, and powers etcd on your behalf, it also uses open source Kubernetes, right? So because of that, and because we have support for upstream Kubernetes, we ourselves do not support native multi-tenancy. And that means each of you need to think about the constructs that we're going to indicate to you today through these primitives, the open source community solutions, the partner products that you could pay for, and a bunch of other things that you need to define based on your requirements and use cases. There are two types of multi-tenancy. So by a show of hands, how many of you are in an ISV? Okay, so a handful. And how many of you are in a customer, an AWS customer? Okay, so the bulk of you are in a customer. So many of you are likely looking for soft multi-tenant design. That means that you you're not necessarily powering external customers. You're powering internal business units, right? And one of the key items here to remember is that these business units likely don't have an intention to exploit the system, right? There's no malicious users that are intending to blow up the platform as a service offering. So you're focused on agility for your organization. You're focused on operational efficiency. But that's very different than hard multi-tenant design. And why? The reason is because hard multi-tenant design is what you need to power a true public PaaS offering. And what that means is that this is hard multi-tenancy takes things one step further. It gives you the ability to ensure that you can operate potential competitors in the same multi-tenant cluster. Imagine you have two financial services companies, right, that are strongly competing with one another. You can now power them both with ensuring adequate segmentation and isolation boundaries. Here, there's a key item to remember. These customers might want to exploit the infrastructure, and more importantly, you need to focus on tenant isolation. So let's take a look at some of the PaaS requirements. So one first thing you have to remember is in a public PaaS offering, if you're using Kubernetes and Amazon EKS, you don't expose the Kubernetes API directly to your customer. Instead, you abstract them from them knowing that you're using Kubernetes at all. They shouldn't know. All they should know is that they have some type of PaaS layer that allows them to operate their applications. So you have to build some type of API on top of the Kubernetes API, or an abstraction layer, what we call the wrapper. You need some type of workload manager. And this is managing the state of those workloads and the declarative APIs within Kubernetes. So the idea here is if, let's say, you, in order to power customer's application A, that's Node.js with Express, with X amount of CPU and memory, what you need to do is you need to invoke the Kubernetes API through the wrapper to invoke and manage those resources, but you need to ensure that your customer knows the state of that workload. And that's where the workload manager comes in. It manages that state for you. A customer endpoint is interesting. So a customer endpoint is your public API or your single page application or client interface that allows your customer to interface with your PaaS solution and them having the ability to create that application through your provided interface. Deployment pipeline. You need a deployment pipeline per tenant. This is incredibly important. No customer wants to know that their code is being built on a server that's shared with another customer. So you need what we call a silo configuration, as we described earlier, for each deployment pipeline per tenant. So potentially that might be a CI/CD job within code pipeline and code build and code commit per tenant. You need a monitoring service as well. You need to know where the state is of the customer's workloads to tell them, hey, your application is crashing. Here are some of the logs. Here's how you solve and troubleshoot the problems in the PaaS layer. And then you need some way to meter. So there's a PaaS layer that we talked about. Let's talk about this PaaS layer that sits on top of Kubernetes. And then we'll talk about how to use Kubernetes for multi-tenant design. So we have a single page application here that you could see. It could be any type of static website, React, it doesn't matter. What it's doing is it's invoking some type of API where you have the ability to authenticate and authorize a user. And what you're doing is you're actually using a Lambda function to decode the identity of that specific user within that tenant. So perhaps this is an OIDC within Amazon Cognito, right? OIDC identity, OpenID Connect identity that has a specific username and password linked to some type of custom key value pair that indicates this is customer with an identifier of A, or tenant 1. Then after you know who they are and you figure out who they're authorized, what access they're authorized to, then what you need is you need to be able to have them invoke, I want to create a new application. So here, what we're doing, and this, by the way, this infrastructure that we're using here really isn't the core point. The core point is that you need to build an API layer on top of the PaaS if you want a true public PaaS offering. How you do it is likely a nuance. So here we have the workload manager that's managing the state of these workloads, and it's responsible for digesting the required resources that Kubernetes needs to be able to be provisioned from a primitives perspective. It will make sure that it's invoking the Kubernetes API wrapper to say, hey, go ahead and call our EKS cluster and create a namespace and a pod and so on and so forth. Finally, we need the customer to know what the state of their workload is. So that means that we need them to be able to call some other similar API to say, hey, now that I've created my workload, where is it? So I want to hand off to Ranjith, who's going to dive deep with you on how to achieve compute isolation at the Kubernetes level now. So Ranjith, come up here.
All right, thank you, Judah. Hey, everyone. So Judah talked about some of the challenges in achieving true multi-tenancy in a Kubernetes environment. So what I'm going to do right now is walk you through some of the Kubernetes features that could potentially help address those challenges. And in my first section called compute isolation, I'll be covering some of the isolation techniques like, namespace per tenant, and how can you use service account for segmenting the resources within a namespace. And then finally, resource isolation with things like pod security policies. So namespaces, it provides a logical isolation of one tenant's resources over others. In other words, if you have a large Kubernetes cluster, by using namespaces, you can segment them into multiple smaller virtual clusters. So the strength with the namespace is that it provides an obfuscation of one tenant's resources within a pooled environment, but there is also a challenge or a weakness with namespace in that resources within one namespace can still access resources, resources in a different namespace, right? So now, as a SaaS provider, you may think that, well, I don't want multiple tenants or tenants in my my cluster to be talking to each other or exchanging data or resources between each other, right? Or or maybe some of you may even think that maybe I should just spin up separate cluster per tenant. So the problem with that is you would soon realize that it's highly cost prohibitive. Like if you want to maintain separate clusters for each tenant, it does not work out that well, right? And it also does not make a lot of sense from a maintenance standpoint if you have to maintain individual clusters for each tenant. So you still have to think about how you're going to make this work within a pooled environment or within a shared cluster. So Kubernetes provides an authentication and authorization module, right? So imagine a request coming into a Kubernetes API server. One of the first thing it does is authentication, right? In the case of Amazon EKS, it goes through the identity and access management service, right? So your request gets authenticated, and then it moves to authorization modules. So now the Kubernetes authorization, there are several techniques, right? I mean, you have node-based authorization, you have attribute-based, you have things like webhooks that you can create. But the one that I'm going to focus today is Kubernetes RBAC, or Kubernetes role-based access control. One of the fundamental concepts in Kubernetes RBAC is this concept of a role, right? So a role it's a set of rules which has a list of permissions. And then I'm going to cover service accounts and how you can use service accounts. So you can think of service account as a user, but the difference is it's within a namespace. It's for an application inside a namespace. And then finally, role binding. So now we created the service account and we have the role. Role binding binds the service account to the list of permissions that we defined inside the role. And this is an example of a service account, pretty straightforward, right? So it resides within a namespace called tenant1. And this is a role, right? Again, it resides in the same namespace called tenant1. And in the rules section, you can see that it has a list of permissions like get or watch or create or update over a set of resources like replica sets or pods or deployments. And finally, we have the role binding. It's again in the same tenant namespace called tenant1, and it binds the service account with the actual role. So now, as a cluster admin of a SaaS provider, or maybe you're just building a SaaS application, you may think that, okay, I created namespaces, so I was able to achieve some level of logical isolation, and then I created my Kubernetes RBAC roles and my service accounts. So I'm all set, right? I was able to secure my cluster. Guess what? You're not, right? Because a user or a service account within a namespace can still access the internals of the node that they're on, and they can potentially wreak havoc. I mean, they can access file systems, access devices, unless you explicitly block them. And the way you would do that is by using pod security policies. So pod security policies, they are a cluster-level resource that controls the sensitive security aspect of the pod specification. And what that means is it defines what a pod can do and what a pod cannot do, right? It's also a set of conditions that the pods must meet in order to be accepted by the cluster. Now, there are several things that a pod security policy can control, like things like EC2 instances, file systems, networks, namespaces, and volumes. But the fundamental idea that you need to keep in mind is you are trying to prevent a custom application of one tenant from somehow or by some means access a different tenant's resources. Disable privilege mode. So this is probably the most important concept that you need to keep in mind. And I do have an example of this in my next. Yeah. So this is an example of a pod security policy where you can see that the privilege flag is set to false. So this means you're preventing a user from creating a privileged container. So a privileged container is a container that has elevated access, a privileged access that could potentially access the internals of the node or access the file systems or devices, right? So this is something that you don't want to allow, especially in a multi-tenant cluster. And you can see that I also have set must run as non-root, and this is because you don't want a user to spin up containers that has access to root privileges, right? That has root privileges. So one important thing to note here is Amazon EKS, starting from version 1.13 and above, has the pod security policy admission plugin enabled by default. And what this means is, so let's say you're logged into Amazon EKS cluster. If you do kubectl get PSP, PSP stands for pod security policy, you are going to see a default pod security policy by the name EKS.privileged, right? And if you describe that, you're going to see everything that I talked about. You're going to see like things like allow privilege set to true, allow access to host network set to true, which is ideally, that's something you don't want. And the reason it's this way is because to maintain, backwards compatibility with clusters that did not have, admission plugin controller enabled. But as a SaaS provider, what you need to think of is you have to create a more restrictive policy. You don't want this, right? So follow the guidelines, that I talked about in my previous slides. Create a more restrictive policy, and disable the privilege flag, or set the allow access to the host network and things like that. So, just disable those so that you can apply that more restrictive policy, and then delete the default EKS.privilege policy that you see here. So I talked about how we can use authorization and pod security policies, but there are certain things that you need to keep in mind when it comes to securing a platform from an authentication perspective, right? And one of the first thing is never expose your service account, right? So tenants in a PaaS type solution should never have access to the Kubernetes API server, never. And pull secrets from vault. So think about how you can programmatically, programmatically use service accounts to get or pull the Kubernetes secrets from a secret storage location like vault. Consider federation. So think about how you can inject the tenant identifier. If you're using an OIDC type identity provider, the OpenID Connect. So think about how you can inject the identity provider. Think about how you can inject the tenant identifier into the request, so you can monitor the request that flows through your cluster for better and for adequate compliance. So I talked about how you can, control and, isolate some of the isolation techniques at the compute level. So I want to do the same thing at the network level. And some of the concepts that I'll cover here is things like network policies, the concept of a service mesh, and I'll give you some examples of how you can achieve monitoring and compliance. Network policy. So the Kubernetes network policy API provides a standard way for users to define network policies, right? So the idea is to control the flow of network traffic. But there is a challenge with that, because Kubernetes does not have an inbuilt mechanism to enforce that particular network policy, right? And in order to do the enforcement, you have to use some kind of a network plugin. So, for example, there are plugins like Tigera Calico or Weave or Romana, and there are a few others. And if you need advanced capabilities, you can use Tigera Secure. So a big part of defining a network policy, it revolves around two concepts: ingress and egress. So ingress is the traffic coming into the pod, and egress is traffic leaving the pod, right? And I do have so the example right here, it shows I've blocked both the ingress and egress on any pods in this particular namespace called tenant 1. So this is sort of a best practice that you could follow, right? So always start with maximum restriction when you're building applications, right? And then slowly open things up, right? And this is a slightly more advanced example where you can see that I'm opening up traffic between the front-end pod and the back-end pod using pod selectors, and we are still within the same namespace called tenant 1. And in this slide, I'm going to show you an example of a multi-tenant use case, right? So I'll walk you through a series of steps that, where you can see that when I introduce a network policy that blocks traffic, you can see a failure, of communication between the two tenants. And I'm going to start off with, the commands that you see right here, which is kubectl create namespace. So you're creating two namespaces pretty much, right? And then you would create an Nginx pod, and then you would expose that pod on port 80 across both the namespaces. And then I'm creating a bash pod or a pod which to which I have terminal access to in namespace in tenant 1 namespace. Then I create a cross-tenant traffic, right? So I try to use curl and access both the Nginx services in both the tenant namespaces, and I get a success. Now, I'm applying a network policy that denies all the traffic coming into the pod and going out of the pod. And let's see what happens. And now, obviously you have to apply that network policy on, across both the tenant namespaces. And you can see that, there is a failure, when you try to, if you go back to the bash pod that we created in tenant 1 namespace and try to do the curl command again, and try to access the Nginx service in tenant 2, you would get a failure because now we added a network policy that would actually block the communication or the traffic between, the two tenant namespaces. So I touched upon this a little bit in, in one of my previous slides. So if you need advanced capabilities like, in-transit encryption or better monitoring, or if you need, alerting when there's a cross-tenant traffic event, right? Or maybe, you want to maintain continuous compliance, right? So Tigera Secure is a really good option. It's a paid product, but it's a really good option that, something that, you can check out. So now, Atlassian, they have a multi-tenant offering on top of Amazon Web Services, and they use Kubernetes to, to isolate their workloads, right? And they do this appropriately using, Tigera Calico at the network level. And this is a testimonial from Atlassian, from a senior team leader at Atlassian on how Tigera Calico helped us, or helped them achieve network isolation. So I talked about network policies, right? So network policies helps you block traffic between namespaces, and but there's also a challenge with creating network policies. One of the challenges, things like managing IP blocks, right? So IP blocks when it comes to managing ingress and egresses, right? So it can get a bit repetitive and cumbersome. Imagine someone sitting there and just managing all the CIDR blocks, and it's not fun, right? So there are definitely better options, and one such option is the idea of a service mesh. So service mesh, it creates a logical boundary for your traffic, right? With traffic between your services, and it achieves this by using virtual services and virtual routers, virtual nodes. And the main thing to remember or keep in mind is you can create fine-grained destination routes and rules with service mesh. You can do things like rate limiting using quota rules, and you can do things like deny rules, a better version of whitelisting and blacklisting, unlike with network policies. So these are some of the examples of service mesh. AWS has app mesh, and then Istio, console, Linkerd. Superglue is a really interesting project. It provides orchestration of multiple meshes. So something, if you're interested, you can check that out. And these are some of the features of service meshes, right? So it provides load balancing, things like routing, circuit breaking, obfuscation, service discovery, right? And I'm not going to, talk about all these in detail because these are, inbuilt features of service mesh. But my main focus here is to talk about multi-tenancy with a service mesh, right? So things like tenant routing. So how can you create, intelligent routes to manage traffic between service mesh silos? Network isolation, I've been talking about network isolation for the past few minutes. So with a service mesh, think about, do you need one control plane and multiple meshes per tenant, or do you create one control plane and a mesh per tenant, right? So when you design systems, like you need to think about all that. And then you can further obfuscate, with a service mesh, you can encapsulate all the tenant activity, within a service mesh silo. Things like service discovery and canary deployments is where you get A/B style testing, and you can create canary style deployment rules. And obviously, multi-region is where you can extend your mesh across Kubernetes clusters so that you get better disaster recovery and things like multi-region deployments. Tenant tiering and quality. So this is, if you're a SaaS provider, this is probably one of the most important topics that that you have to keep in mind, because this is where you can control the amount of resources that a particular tenant would consume, right? Because when you have several users or teams of users or tenants sharing one cluster with a fixed number of nodes, there can be a fair concern that one tenant may use more than their fair share of resources, right? So that's where so Kubernetes provides several options, and one of the options is something called resource quotas. So resource quotas, it helps you limit the amount of resource a particular tenant can consume. And it does this by setting quotas and limits on things like, you can control things like CPU or memory or storage. But on top of that, it lets you limit the type of resource you can create. For example, if you want a tenant not to spin up more than 10 pods or 5 or 10 pods in the cluster, you can actually define a hard limit in a resource quota definition file. You can do things like performance and enforce performance and capacity tiering for CPU, memory, and storage, manage tenant pod prioritization, and this last point here is probably one of the most important one, because if you set one of the biggest advantage of setting resource quotas is you can minimize the blast radius when there is one particular tenant consuming more than their fair share of resources. When there's an overconsumption event, resource quotas helps you define that limit. And what happens to that tenant is, like, if they're overconsuming on CPU, they'll get throttled. If they are overconsuming on memory, they'll just get an error. And this is an example of resource quota, and here you can see that I'm setting a hard limit of 5 and 5 for the number of pods, and then I'm limiting the CPU. The maximum is 2, and the memory limit is 4 gigs. So I talked about resource quotas and how resource quotas would help you manage and restrict a tenant's resource consumption. But let's say there's a tenant that has to meet like strict regulatory requirements. They want to run their workloads on an isolated node where they don't want to share their workloads with any other tenant, right? So Kubernetes provides a feature called node affinity, right? So which constrains which nodes a tenant's pods would be deployed to, right? And you can achieve this by using labels and selectors. It also, Kubernetes also provides another feature called pod affinity and pod anti-affinity. What this is it's a set of rules that you can specify, how a tenant pod should be placed in relation to a different tenant's pod. But the fundamental idea here is, you're preventing the scheduling of a tenant pod on the same node as that of a different tenant's pod. You're creating that isolation for your special tenants. So this is very similar to the previous slide, right? The objective is very similar because there's a tenant. So let's say there is a tenant that wants to run like a high CPU intensive workload, right? Or maybe there is a tenant that says, hey, I want my pod or I want my workload to be placed on a node that has a solid state drive or an SSD. How would you enforce that, right? So Kubernetes provides features like taints and tolerations, where taint is, it lets you taint or mark a node so that the Kubernetes scheduler exactly knows which pods it should place on the node and which pods it should not. And toleration is, it lets you designate pods that can go on a specific tainted node. And if you think about this is exactly the opposite of what I was describing earlier with node affinity, right? With node affinity, you have a set of pods getting attracted towards a node. But with taints and tolerations, you have a node that's basically rippling away pods unless or until it finds a corresponding pod or a pod with the corresponding toleration, right? So very similar objective, but the way it works is exactly the opposite, right? And this is how you do it. I mean, kubectl taint nodes, you would provide the node name, and then you would provide a key and a value, right? And then when you define a pod, you need to actually add a toleration section where you specify the key and the value that you use to taint that particular node. So this way, when the Kubernetes scheduler sees this pod coming into the queue, it would exactly know which node it should place this workload or it should place this pod onto. Managing eviction through priority. And so this is a classic tiering example or use case where, so let's say you're a SaaS provider and you have tenants in 3 different tiers, like basic, advanced, or premium, and you want to provide more value for your premium users, right? Because obviously they pay more money. So what you can do is you can set their pods with a priority. So priority is just a number, it's just a numerical value that you can set. And what it indicates is, it indicates the importance of one pod in relation to different pod. So, for example, a higher priority pod would be placed in front of the queue. So now the Kubernetes scheduler, it maintains a scheduling queue, and that's how it places all the requests that it has in the queue onto the nodes. So when it sees a higher priority pod, it goes in front of the queue and it gets more preference over the lower priority pods. And prioritized tenants are based on planned tiers. So this is something which I already covered. So if you want to give more value for your premium users, you can set a high priority for those pods. So preemption, it's an interesting technique where, so let's say you're running a cluster and it's running into some kind of a space issue, right? And and a higher priority pod comes into the queue at the same time. What happens is the Kubernetes scheduler would actually evict a lower priority pod from the node, and it would replace that with this high priority pod. It sounds cruel, but that's how it works. But one thing you need to be mindful of is how you assign these priority values. Because if you assign a high priority value for so let's say a workload or a pod for a tenant that's in the basic tier, so it can potentially evict other tenants' pods, which is something you don't want, right? So it can cause a lot of noise in the cluster if you don't assign the priority values properly. Graceful tenant task termination for preemption victims. So every pod has a graceful task termination period. So the default in Kubernetes is 30 seconds. So it's a time when the pod is being preempted. And so when a pod is getting preempted, it has 30 seconds to go back into the scheduling queue to be eventually placed back into the node. So now that may not work for all the tenants. So some tenants would be just running stateless apps, right? And they would be like, okay, I don't want that 30 seconds limit. So what you need to do is lower that limit to maybe 0 or maybe to a really low number so that those victim pods or preempted pods can go back into the queue pretty quickly to be eventually placed back into the node, right? So something you need to keep in mind when you're working with priority values or priority and preemption. So with this, I want to hand it over back to Judah to talk about storage isolation.
Thanks, Ranjith. So now that Ranjith covered some of the considerations for network isolation and for compute isolation and tiering, I want to talk to you about how to achieve some of the corresponding requirements that you have for storage isolation for multi-tenancy. So I'm going to cover 3 core concepts here with you. There's a lot more to it than that, but one is going to be subfolder and folder isolation. One's going to be persistent volume isolation, which is a volume like an EFS cluster or a EBS volume per tenant, and AWS resource isolation, such as like using AWS resources like Amazon's S3 or DynamoDB through AWS identity and access management roles. So let's start by talking about how you achieve it with the folder, subfolder, and the volume. So artifact roles are this concept that limit the physical volumes a tenant namespace can access. So the namespace, for all intents and purposes, is our tenant. And PVC claims can limit a tenant's access to NFS volume subfolders through Kubernetes role-based access control. So PVC claims are a little bit of the secret sauce here. Now, but one important distinction to be aware of is storage classes exist at the cluster level, but not at the namespace. So the way that you need to do this is actually to deny, you need to use storage resource quotas specifically to limit it based on the specific namespace. And to deny a specific namespace specifically to a specific storage, if, for example, like one tenant can absolutely never access this other one, which is pretty common in a multi-tenant design, you set the resource quota to 0 for that storage class. So that's one approach. Let's talk about now the AWS approach for managing resources in AWS. So many of you may be familiar with a solution called KIAM or Kube to IAM, which is our legacy of open source solution that was leveraged by our customers and our ISVs to be able to provide access to identity and access management roles within AWS IAM that are scoped to tenancy. Now, recently, AWS came out with this new AWS IAM roles for service accounts feature, which allows you to give pods in a namespace access to a specific AWS IAM role that's scoped to a tenant. And the reason why this is really valuable is because you could go ahead and create a role for, let's say, Amazon's S3 and say that that role in AWS IAM could only access a tag of assets that have a tag within S3 of tenant identifier like 1, or where it's a prefix like /tenant1 or /a GUID that would be specifically for that tenant. So this makes pods a first-class citizen in IAM, and this is important. More importantly than that, it allows AWS Identity APIs to recognize Kubernetes pods, which is going to give us the opportunity to introduce a large number of features as we start to introduce this, and it penetrates our platform more richly through the next year. One consideration to think about here is you could actually leverage service accounts and with OpenID Connect, which is an identity provider that allows you to federate through JSON Web Tokens, which are an approach for securing client-side authentication for a user. And what's interesting is you could actually now go ahead and use service account annotations to use these IAM roles at the pod level and send this request completely downstream. So what you could do is you could say, I'm going to ensure that for every request, the JWT is what's used to scope the access to these credentials at runtime, which is pretty valuable as well. And the way that this works is you exchange the OIDC JSON Web Token with what we call security token service credentials. These are temporary credentials, not long-running like AWS SDK access and secret keys. These are temporary access secret key, which includes session duration and a session token. And the great thing here is that you can ultimately use these SES credentials within your pods to be able to access S3 from your applications. One big key differentiator between this and some of the open source products that do something similar is that we are actually hosting this on the EKS control plane, and we're managing it on your behalf, so it's additionally secure because you can't control that master. So here's an example for how you could actually implement it. So you can see here that I have tenant1 role. I could name that whatever I want, but that's the easiest way to see that I specifically have tenant1 role, which is a specific role for tenant1 that's allocated to tenant1-service account 1. Why did I have -service account 1, you might ask? So typically for compliance, the regulatory authorities require you to know what's happening at a service account or a deployment or an application level. So because of that, the distinction and best practice is always to have a service account within a tenant per microservice or per PaaS workload that your customer has. So a big thing that each of you want to know is, how could I not spend a lot of money on this? Or how could I operationally, operationalize this PaaS solution for cost? So I want to talk about some of the design considerations. So resource aggregation is an important concept. So imagine that you have 3 nodes that are underutilized significantly. That means that you can't charge your customers for that capacity, and it's wasting your money. Now, you still need a certain amount of excess capacity to scale, right? Across the horizontal pod autoscaler and the cluster autoscaler, we all know. But one clear important thing to remember is you don't want to leave too much excess capacity, because then you're paying idly. So you've gone ahead and meter the cluster usage, the CPU, the memory, the storage for each tenant. And in the next slide, I'll describe how you could do that. You're going to develop tiering strategies, and you're going to develop budgets. So I want to give a great example that I have with a lot of the ISVs that are exposing PaaS solutions. Many of these providers are looking for a free tier. The free tier costs them money out of their marketing budget, typically, or maybe out of the sales organization. And this is literally like they're not obtaining any potential revenue from that free tier. So one of the key things to think about is if you deliver a specific budget per that plan type, then you know that the free tier will never exceed excess amount of capacity above a specified threshold of X amount of dollars. And that's why that's valuable. Develop performance and tenant SLA tiering is important. So one of the ways to differentiate your products is by providing better SLAs for customers that pay more, right? It's just a typical tiering strategy. What you're going to do after you grab these metrics is you're going to use this information, this metering information that's pulled on a regular basis to drive what we call entitlements. Entitlements is likely some type of document that says customer with this following identifier has access to the following resources, and this is what they're entitled to use. So what you could do is you could say this customer has exceeded their capacity, and you can communicate to your inside or field sales organization that they need to go ahead and promote that customer to the next tier through sales conversations. Alternatively, if it's consumption-based pricing, you're likely using that for showback to prove to them that they're using that consumption and to charge them back, right? Because if you're charging them on a consumption basis, let's say based on the number of CPU cores and the amount of memory for gigabytes, you need to be able to do that, and you'll show that to them also for compliance. So one key thing to remember here, we talk about all of these concepts and they all combine to one typical strategy that our SaaS Factory team has branded cost per tenant. Cost per tenant is aligning your cost structure in AWS to the cost structure required for how you're going to monetize the offering. So if you are paying most of your money is going to CPU and memory and storage, that means you want to meter CPU, memory, and storage and charge your customer likely some type of additional margin on top of what AWS is charging you. That is cost per tenant. So you're going to tie the consumption to native Kubernetes constructs, and you can do this through pods, persistent volumes, storage classes, and other resources as well. Okay, so now that we talked about why and kind of conceptually, what to do, we're going to talk about how to do it. So Kubernetes has an API and a metrics server that exposes metrics for like pods in a namespace and amount of compute and memory. So what you could do is you could expose these kube state metrics through solutions such as Prometheus or through CloudWatch Container Insights, which is a new feature that we have within Amazon's CloudWatch that exposes metrics for not just Kubernetes that's in Amazon EKS, but native Kubernetes as well as through through ECS. And what you're going to do is you're going to expose the number of pods per hour, the pod usage per hour. So if you have, let's say, 5 pods, and that pod, each pod of those has like 1 CPU and 1 gig of memory, you have 5 CPUs and 5 gigs of memory for that specific interval of that hour. So you know how much it costs you, because then you could pull the EC2 instance type, and know exactly how much it's costing you to operate that customer. Then you need some way to digest these metrics in real time. And that's where an analytics pipeline comes in. So you likely have some Lambda functions to expose metrics. Maybe these are API invocations within your application, and you're going to correlate those API requests to that corresponding infrastructure cost, or potentially you'll regularly poll for those metrics as well. There's 2 typical approaches. So polling is, I want to get it at this moment in time. How much are they using? That's one strategy for monetization. The other approach is, when did my container start? When did it stop? How many minutes did they consume? Because in EC2, you could charge at a per minute level, right? That's how we can monetize the offering ourselves. So potentially you want to meter and sell to your customer at a per minute level as well. You'll pull tenant metrics into some real-time dashboard. Analytics pipeline like Kinesis with Kinesis Analytics, and maybe like Elasticsearch with Kibana, and you'll digest these metrics into some type of consumption unit. This is your billable unit. So you've aggregated the records, you've made intelligence of them, you know how you want to sell, and then you're going to go ahead and create some type of dimension. Dimension, for those not familiar with subscription billing vendors, is it's this technical concept that applies pretty much to a SKU or a feature within a larger product listing. So you might have, like, let's say 24 dimensions that could be supported in one product listing in AWS Marketplace if you're selling a SaaS product, right? So each one of those is monetized at a different price. So if somebody consumes 3 units of a feature A, that's a specific price for feature A. So a great example of this is, in AWS Marketplace is Dynatrace. So Dynatrace is a vendor that sells on the AWS Marketplace that monetizes based on their corresponding features. And then finally, you're going to send these records to that billing API with the intent of having that bill show up. So there's another approach that I want you to be aware of. So my approach is conceptual. I want to go into a little bit more tangible approach for just a moment here, because this is a thing that I hear quite often from customers. So Slalom is a system integrator, an AWS partner, who actually written and authored a blog post that I had reviewed as well with our APN SaaS Factory team. And what they did was they decided to expose the number of API requests processed and the execution time per use case, and they correlated that to the amount of CPU and memory that that specific use case would leverage. How did they do that? So they had to expose it both at the database invocation layer, maybe through the DAO layer, as well as through the service invocation layer as well. So they exposed things such as domain, timestamp, tenant ID, metrics. They also exposed those same metrics I just talked to you about before, like CPU, memory, storage. And then what they did was they aggregated these all into these specific metrics, where these metrics potentially could be those dimensions or SKUs that we talked about earlier, for the intent of billing the customer. One key item here is cost per tenant is a much broader conversation than just Kubernetes. You have to think about a large number of AWS services. Two services to think about that I often hear from customers is, how do I do multi-tenant S3 buckets? And it's really challenging to meter S3 buckets unless you have some type of proxy that's actually metering those requests. So what Slalom did was they suggested single tenant S3 buckets in cloud-hardened distributions per tenant. Now, there may be reasons why that doesn't fit the architecture that you want, but it simplified their architecture. So here's kind of how their end state looks from a real-time analytics pipeline perspective for digesting these metrics. I'll give each of you an opportunity to take a screenshot if you want. You can also find this as well on the APN blog. Just search Slalom cost per tenant. Wait another minute. OK, so let's get into some advanced architectures. So hardware isolation. So containers have a lot of limitations. Those familiar with the Kubernetes CVEs, the Docker CVEs, there's a lot of limitations in containers, especially in Docker containers. So hardware isolation gives you the ability to have an additional layer of isolation and restriction for the containers that you're operating through what we call Kata containers, which is an open source project and global community working to build a standard implementation for running lightweight virtual machines. And what we did was we built a solution called Firecracker, which could be actually introduced into Kubernetes, right, with the opportunity for you to create micro virtual machines in Kubernetes and power those Docker workloads within that specific micro VM. This allows you to have hardware level isolation at the VM level, and this is actually what AWS is doing for Lambda and for Fargate. So if you want to take this to the next level, and you say, I have really, really hard boundaries, you could take the concepts we applied earlier and mesh them into this. And here's an example of how the Firecracker architecture looks. So Firecracker architecture, you have this guest, which is like a guest operating system. That's and that's a micro VM that's encapsulated with the specific hypervisor sitting underneath within that EC2 instance node on that worker node of the Kubernetes cluster. Within that guest, that's where you place the Docker container or the pod. OK, so one other cool feature. So this is something that's not quite in production yet, but ALB, for those familiar with Application Load Balancer and the ingress controller, many of you know ingress controller allows you to route requests into your cluster through a layer 7 load balancer. Now, one big challenge that we've heard from our customers is that I have to create an ALB per deployment. So that means that I have 60 ALBs if I have 60 potential customers or 60 workloads. And that's really hard to scale, right? So what we're doing with the version 2, that's still kind of in its alpha stage, but will hopefully be out at some point within the next couple months, is we're allowing you to use target groups based on a distinction of a path like /tenant1, domain.com/tenant1 or /tenant2, HTTP header like passing it through an HTTP header like x-tenant ID equals to 1, or alternatively a host header, tenant1.domain.com. And we could do this through target groups. So target groups are this group within ALB, and the ALB ingress controller with version 2 through annotations in Kubernetes will actually allow you to create these specific groups in a dynamic way. And this is super valuable There are some limitations. Right now, application load balancer supports 100 of these rules. So if you have more than 100 tenants, there are some constraints, and that's where service mesh routing comes in, and it could scale much further. But this is a really great consideration to think about as you start to redesign your architectures for 2020. Okay, one other advanced topic here is vertical pod autoscaler for database isolation. So vertical pod autoscaler automatically adjusts the CPU and memory reservations for pods to help right-size your applications. This can free up CPU and memory, but really what I want to talk about it for is it can allow you to scale your database deployments in Kubernetes, and this is super cool. For those familiar with stateful sets that are used typically for Kubernetes databases, right, that are deployed within Kubernetes, one of the challenges you have is it's really hard to scale vertically up and down the amount of compute and memory allocated per database. And if, let's say, you use a database deployment within a stateful set per multiple tenants, you need to scale that amount of capacity to scale to the number of tenants that you're operating within that specific database deployment or cluster. So vertical pod autoscaler is a feature, again, that's still kind of in the works, but will allow you to do that. And it'll allow you to do this based on a dedicated database volume per tenant, or also within a multi-tenant database deployment. So again, the key idea here is the horizontal pod autoscaler scales the number of pods horizontally across a number of pods. The vertical autoscaler doesn't change the number of pods. What it does is it adds more compute and memory to it as it's running. Okay, so there's a lot we didn't cover. And I apologize, but it's a 60-minute session, and I'm almost out of time. But we didn't cover some concepts that are advanced for monitoring. Things such as like how do you do tracing, how do you do real-time observability of like, tenant 1 reaching into tenant 2. How do you do auditing and logging in a multi-tenant world within Kubernetes, right? It's just, unfortunately, we didn't have enough time. We didn't talk about like things such as the open policy agent, which is going to be a new thing that will hopefully allow us to ensure more, kind of more like multi-tenant design native within the Kubernetes primitives. We didn't cover things such as hierarchical namespaces, which is in the works. This is kind of nested tenancy within namespaces, which is super cool, and that's coming out. We didn't talk about gatekeeper and and other approaches for pod security policies and how things are changing. Many of you that attended KubeCon likely know that things are shifting quite a bit from pod security policies in later iterations, and we just couldn't cover that today. Image scanning is something we didn't cover. So ECR, for those not familiar, is a container registry like Docker Hub, right, that we have within AWS. And image scanning is something that you could do to make sure that your dependencies are approved and that they're compliant. More importantly, it ensures an adequate DevSecOps pipeline that will go through your continuous integration and deployment and delivery pipelines. More importantly, we didn't cover DevOps really at all. And I wish we could, but this is a multi-tenant talk. It's not a DevOps talk. So there's a lot more we didn't cover either, but it's really important for you to make sure to take a couple things away. One thing you need to take away is there is no native support for multi-tenancy in Kubernetes. You can only achieve this through some of the primitives that we just provided, some of the open source community tools, things that we didn't mention, but you got to do it yourself. Also, there's a whole bunch of community tools. Tigera Secure will allow you to do encryption per tenant across different namespaces to ensure network traffic isolation at the encryption level. So the community has a whole bunch of products. You need to explore those products because Kubernetes alone is not sufficient. Never expose the API in a public PaaS. If it's an internal business unit PaaS, that's a different story if you're a customer. But if you're exposing this as like a Heroku-style platform, you never expose that specific service account to a customer. Instead, you pull those secrets and you dynamically invoke the API on their behalf. I wanted to make sure that each of you learn about the CVEs that are out there that I didn't have time to cover. There are a lot of them. So please dive deep on Kubernetes, much more than what we covered today. You could talk to Ranjit and I after the session. And finally, make sure you have a silo pipeline. With that said, I want to show you some related sessions. We have a whole bunch of SaaS content. Hopefully this was exciting to you, and there's a whole bunch of content that we're having this week. I have a couple sessions Wednesday and Thursday that are Chalk Talks. They're going to be more interactive. You can ask questions. You can get involved. Ask your real tangible problems that you've been having, and we can answer them. Finally, I want to thank you for this session, but before I have you leave, I want you to pick up your phones for me for just one moment. Everyone pick up their phone, and I want you to bring up the mobile app And please rate us, because if you've liked the content that we've covered today, we really want to be able to present it more to additional customers within the ecosystem. So thank you so much, and have a wonderful day today.